Hello. A parabola has a graph which is U-shaped. There is an axis of symmetry that goes through the vertex of a parabola and splits it into two symmetrical halves. The vertex of a parabola is either the lowest point or the highest point of the parabola, which is also the turning point of it. In this lesson, we'll be also looking into the focus, which is a point inside the parabola, and a line called the directrix, which is outside of the parabola and perpendicular with the axis of symmetry. A parabola can be described as a set of points that are equal distance from the focus and the directrix. For instance, this point has a distance from the focus, which is the same distance from the same point going down perpendicular to the directrix. We can use different forms of equation to describe a parabola. The standard form, or another one called the general form. Going from the standard form to general form, we just open parentheses and rearrange the terms. Going from general form back to standard form requires completing the square. The general form is also called the vertex form because the vertex hk is already in the equation. So the vertex is h comma k. Be careful that h is to be subtracted from x in this standard form, and k is the value you want to add at the end. In fact, you will see hk a lot when you learn about other functions. H is always with the x, and k is always with the y. In fact, h is always subtracted from x, and k is always subtracted from y. And you see that this k here, y is a plus because k is away from y. If you would put k back to the left-hand side, it would be y minus k. Okay, but we use this form to describe this the standard form for the parabola. The distance from focus to vertex is equal to the directrix to the vertex, which is equal to 1 over the product of 4a. 1 over 4a and 1 over 4a. Okay, this distance and this distance. And the length of the line segment, this is lattice rectum, which is the green line segment passing through the focus parallel to the directrix. Its length is 1 over a units long. So we can use a to describe the distance, or likewise, given the distance, we can also work out the value of a. Now, because we're talking about distance, so make sure that you use a positive value. Sometimes you may need to take absolute value on a if it's negative. When you switch x and y in the equation, then instead of getting y equals to x squared, you will have like x equals to y squared. You are actually reflecting the graph in y equals to x line, and you get sideways parabolas. If a is positive, then it opens to the positive side of x. If a is negative, it opens to the negative direction of the x-axis. The vertex does not change. So from the definitions and these characteristics, so we can understand the chart here. In this column, we have y in terms of x squared. So it's an upside or upside down parabola. In the last column, x in terms of y squared. So we have a sideways parabola here. The vertex is always the same, h comma k. And the axis of symmetry in the upside or upside down parabola, it is a vertical line. So it's x equals to a value. And this value, because it goes through the vertex, it has the same x coordinate as the vertex. Likewise, for sideways, we have a y horizontal line, y equals to a value, which is the same value as the y coordinate of the vertex. Now the focus, which is 1 over 4a away from the vertex. So we will start with h and k, but in an upside or upside down parabola, it is above or below the k. So we're going to add 1 over 4a. Now if a is negative, you will end up doing like a subtraction from k. So don't worry about that. So it will take care of the negative value of a. Likewise, in the sideways parabola, so now is the x coordinate change. So we're going to add 1 over 4a to h. And directrix is on the other side of the vertex. So right here we have plus, and right there we have minus. Likewise for the sideways parabola.